G'day, I'm Mike, and welcome to The Point, where today I try and justify every piece of maths you'll ever learn in a few short minutes. No, wait, that's practically impossible. Okay, so why are we studying maths in the first place? Obviously, we're going to cover each topic in more detail as we get to it, but big picture stuff, the reason humans developed mathematics all those millennia ago was basically because we wanted to understand the world around us. And to do that, you need to look for patterns. Patterns like how the stars in the sky are moving and how that's connected to the temperature going up and down over the year, and that's connected to when you can plant your crops, so on and so forth. Mathematics is the language of patterns. Pretty much any time you describe a pattern, you'll at some point be using numbers or shapes or some piece of maths to do it. And it's a very efficient language. I mean, it may look very mysterious and impressive, and that's why it's used a lot in the background of films and TV shows. But every piece of impressive, mysterious mathematics can be translated straight into a sentence in English or whatever language you like. For instance, take this piece of mathematics, written in Greece about 2,300 years ago. It's from a book called Euclid's Elements, which is the most famous maths textbook of all time. And it says, let ABC be a right-angled triangle, having the angle BAC a right angle. I say that the square on BC is equal to the sum of the squares on BC and AC. Translated from Greek to English. All right, well, that's kind of wordy, but all it's saying is, if you have a right-angled triangle, that this squared plus that squared is equal to that squared. That's Pythagoras' theorem. Why did they write it all out in words instead of, this much shorter, nicer form? Well, because they didn't have algebra. That wouldn't be invented until over 1,000 years after this book was written in the Middle East. But it's the same mathematics, just one way it's written in words and the other way is written in a nice, shorter mathematical equation. Maths, if you like, is the original text speak. Right? Long before we had text messages or Twitter that encouraged us to get really short with our sentences and words, mathematicians were all over that, taking these long paragraphs and cutting them right down as far as they could, because mathematicians were very lazy. No, very efficient. Very efficient. So efficient that, for instance, the Scottish mathematician James Clerk Maxwell could take literally everything that was known about electricity and magnetism and condense it down to 4 short equations that can fit on anyone's tiny blackboard. And this language of patterns is practical, right? It came out of practical needs and it continues to serve practical purposes. Just sometimes there's a bit of a difference in timescales between when you discover mathematics and when it finds a use. Pythagoras' theorem was immediately useful to the ancient Greeks and today for construction because you can measure right angles just by measuring lengths. But things like complex numbers were only really practically useful like 400 years after they were first discovered. But wow, are they useful. I mean, everything around you that has a computer chip in it, for instance, you can sort of thank complex numbers for that. Sometimes mathematicians think that the work they're doing won't ever be of practical use. I mean, the most famous example is the mathematician Godfrey Hardy, who wrote a famous book in 1940 in which he celebrated the fact that he, quote, had never done anything useful. But despite that, quote, he may be judged to have created something worth creating, like a piece of art that's beautiful for its own sake, but not necessarily practical. Fair enough, except decades and decades after he wrote that, his work in number theory is now finding all these applications in quantum and atomic physics. So the issue of timescales. Another example is, let's say, the mathematics of prime numbers, which is just about as impractical a piece of pure mathematics as you can think of. But even though prime numbers have been studied for millennia, since the ancient Greeks, again, they have a very practical use today in the last couple of decades because every piece of information we send out online, in particular our credit card details when we're making online purchases, is encoded and decoded using mathematics of prime numbers. If anyone ever figures out a way to quickly take a large number and break it down into its prime number factors, then we're going to need to come up with a new way to code our online details so no one can read our credit cards. Right? So maths is everywhere. And the thing about maths is that I find it's either really, really simple stuff or really amazingly complicated, never ever going to work it out stuff. And you use the simple stuff all the time without necessarily thinking of it as maths, like figuring out how much stuff you can buy with the money you have. And all the amazingly super hard complicated stuff is done for you and is hidden in the background. Like, think about how much mathematics goes into taking an audio and video recording, translating it into a whole bunch of zeros and ones, and sending all those numbers across the world through the air, off satellites, and eventually into your device, which converts it back from zeros and ones to audio video so you can watch me talking about it. To take one example of how much maths goes on behind the scenes in our lives. The fact that all this technology that our society is built on has all this maths in it is a great reason to know something about it and understand how it works. And by the way, all that maths isn't inherently simple or inherently complicated. It's just the simple stuff is the maths that you already know really well. And the complicated stuff is just the maths that you haven't learnt fully yet. And it doesn't seem to be much middle ground, which is a big reason I think that maths has this image problem. I mean, 7 times 9, for instance. That was once a really complicated problem for me, and now it's a simple problem because I learnt how to do it, and now I understand it really well. And it's the same with every piece of mathematics. So you're doing a lot of maths that you don't necessarily think of as maths because it's not super hard. But that's because you know it, so nice work. And one final point, all of those patterns, all that algebra and geometry and calculus and all of that isn't actually the main point of your maths classes. That sounds kind of strange, but to take an example, when I studied English, first we learned about spelling and grammar and how to put a sentence together and that kind of stuff, and then we looked at Shakespeare's plays and a bunch of other different texts and deconstructed them and looked at all the techniques that had been used and wrote essays analyzing them in depth. But the main point of English wasn't all of that stuff. I mean, I could be tempted to say I'm never going to need any of that because, hey, I've got autocorrect for my spelling and grammar, and I'm not going to be an actor or a director, so don't really need to know how to build a Shakespearean play. But that wasn't the point. The point was to teach us how to communicate clearly, how to build an argument, and how to take a critical look at all of the books and films and advertising and the stories that we see and figure out what the author is really trying to say and how they're getting that message across. And all of those are incredibly useful skills, right? So back to mathematics. In a similar way, the point isn't being able to solve Pythagoras' theorem, though that's nice to know, especially if you are working in construction or building your own DIY project. But the point is to learn how to think logically and how to solve problems. I mean, figuring out how to solve a problem you have by figuring out what you know, what information is important, what you need to know, and how to connect what you know to what you need to know is hugely important. And solving problems is the whole point of mathematics. If you have any questions from watching this video or from otherwise you'd like us to answer, then send them through to us through the comments or through our social media sites like our Facebook page, which is also a great place to meet other awesome people and to ask them questions too. Don't forget to subscribe so you get these videos delivered fresh. If you find them useful, send us a like. Have a good one, and we'll see you next time on The Point.